Hey, we're looking at 232. And how can we find products efficiently using generic rectangles? So our focus is to continue our development of multiplication with generic rectangles. In the previous lesson, you learned a new strategy for modeling multiplication, the generic rectangle. Today you will explore the use of this model in more depth. Later in this course and future courses, you will discover that generic rectangles are a powerful method to represent multiplication. You can use them to find the product of any pair of factors, including positive and negative integers, portions, and expressions with variables. So as we go through this, you might think, wow, why do we got to do all this? Just knowing all of the mathematics and where we have to go with this really will pay off down the road. Expressions with variables and things like that. So I know that this might seem tedious. It might seem like you're taking, like this isn't necessary or anything like that. But I think it will help with a lot of the stuff that you're going to see later on in math, okay? So just be patient and continue to develop your knowledge here, all right? So again, just a reminder, this is called the generic rectangle. And because it does look like a rectangle, right? And we call it the generic, meaning it's a rectangle that we can use with all different types of multiplication, right? 2-68. Alan wanted to use generic rectangles to help him multiply 325 and 46. He started the diagram below. So there's the diagram right here. And we haven't seen this yet with a 3-digit number, 325 and then 46, okay? So what we have is we have two lengths. Or if we go over, let's start over here. Here's that 46, right? So if we look at that 46, this part is the 40, right? And then the bottom part is what? I need a different color here. We'll call that 6, okay? So what we have is that 40 plus 6, right? Those two lengths equal a total of 46. Now, just because I know where we're going with this, I'm going to go ahead and you don't have to do something like this, but it's super helpful, I feel like. If we know that this length from here to here is 40, then I also know that this length of this side of the right side of the rectangle is also 40. If this one's 40, then this piece is 40. And if the far one, then the far one's also 40. The reason I'm doing that is while I'm in here with these colors, I'm just going to label all the side lengths that match up with those colors. So again, if this is 6, right, then this one's 6. Whoops, it wasn't in there. Then this piece is 6, and that piece is 6, and that piece is 6, right? All right. Now let's go ahead and I'm going to remind ourselves through addition that those three pieces added up will equal 325, right? Red, orange, yellow. Let's do green here is our 300, 300, and 300, right? Again, you don't have to write those lengths, but I think it helps us to see those. And we'll call this one what? The 20. That's the tens place. Here's my 20. There's my 20. And then we'll go here and, excuse me, this is 5. And I'll have to zoom in here a little bit. That's 5 and that's 5, right? All right. Let's look at this rectangle right there. We're going to focus in on the biggest rectangle. And to find the area, sorry. So I jumped the gun. Basically, we're supposed to fill in the blanks, and I did that, didn't I? I didn't even read A, but I filled in the blanks, writing numbers that represent the rectangle's dimensions broken apart into their place value components. Alan did not necessarily draw his generic rectangles to scale, so the parts may not match base 10 blocks. Already did it, right? And all of these right here are bonus ones. Those are not ones I had to put in there, but I put them in there to help us see that, okay? Now find the product. So we're looking at B. Now find the product. To do this, first calculate the areas represented by each of the 6 small rectangles. Right? There's the 6 rectangles. 1, 2, 3, 4, 5, and then this little guy's 6, right? Those are the 6 rectangles. Then add up those areas of those small rectangles to find the total area of the large generic rectangle. Okay, I'm going to focus in on just that big rectangle. The area of every rectangle is its length times its width. Its length times its width. All right, length times width. Now when I multiply this, I have little tricks sometimes that help us. 3 times 4 is 12. And then we have 1, 2, 3 zeros left over. There we go. 12,000. You can check it if you had to or multiply it on the side, but that's the benefit of having all these zeros in there. We're looking at the bottom one now. Length is 300. Width is 6. 3 times 6 is 18. Width, 2 zeros left over, 1,800. Let's look at that rectangle right there. The length of that is 40. The width is 20. What is the area of that one? 4 times 2 is 8, with 2 zeros left over. Let's go down here in the bottom one. Length is 20. I don't know if I'm going to have enough room, will I? Let's do this. Right? Length is 20 times the width, which is 6. What does that equal? 6 times 2 is 12, with a 0 at the end, 120. This one right here, the length is 40. The width is 5. 4 times 5 is 20, with a 0 left over. And then down here in that corner, it is 6 times 5, which is 30. There we go. Now, what did we have to do? We had to add up the areas of the small rectangles to find the total area. Okay, so now I could do that on the side. 12,000 plus 1,800 plus 800 plus 120 plus 200 plus 30. Even though I'm adding them up, they don't have to be in order. I just kind of picked a method and went with that. When you add up all of those, you will get 14,950. I encourage you to do the addition on there. I was just making it quicker by just giving you that area that I'd previously calculated, okay? So write your answers numerical multiplication sentence. Numerical means numbers, multiplication, division, signs, plus signs, all that stuff, but we're asking for a numerical multiplication sentence as a sum. As a sum. So what is our total, right? So the numerical expression is multiplication is 325 times 46. So that's 325 times 46. What's the total sum? 14,950. Okay? All right, let's move down here now into 2-61. I started to do some of the work ahead of time here. So let's read this first. Draw generic rectangles to help you multiply the following numbers without a calculator. Show the place value of each part of the rectangle, numbers on the outside of the rectangle, the area of each inside, and the area of the whole rectangle. Make sure your solution is written as a numerical expression and sum, just like you did in problem 2-60 part C. Okay? So what we're looking for down here is this is the 25 times 18 part, and we're going to get that answer right here. Okay? All right, so let's put our focus on this one. I'll take my time to do this one, and then I'm going to move much quicker in the other three to keep the video at a manageable time. So the top part could be a full length of 25. Then that means that this piece could be the 20 plus, and that could be the 5, right? Now, I am not, excuse me, I'm not drawing to this to any sort of scale or anything like that, okay? Because obviously that's not a length of 20 and the other one's 5. They almost look much closer together than apart, right? Okay, so again, if this is 20, that's 20, that's 20, 10 and 10, 5 and 5, 8 and 8. Focus in on each rectangle, right? This one is 20 times 10 to give me 200. We move down. This one's 20 times 8, which is 160. This one is 10 times 5 to give me 50. And down here is 8 times 5 to give me 40. Okay. So what we would have to do is add up all those pieces, 200 plus 160 plus 50 plus 40, add those up. If you take your time to add them up, you should get 450. Okay. There it is. We have, let's make sure we do this. So the area, we showed the place value of each part of the rectangle, right? We did the numbers on the outside. We did the area of each part, and we did the area of the whole rectangle, which we showed here. Make sure your solution is written as a numerical part, and we did that there. You're asked to do the same thing. I'm going to do this. Here's what I would like you to do. I'd like you to try these 4 problems on your own, pause the video, and come back and try it. What I'm going to do is very quickly go through these so that you can check them, okay? Very quickly. All right. So when we do this, this one's going to be 100 times 20, so that's 2,000. The bottom one is going to be 100 times 5, that's 500. To the upper right, we have 20 times 50, that one's going to be 1,000. We go down there, 50 times 5 is 250. In the upper right, we have 20 times 3, that's 60. And in the lower right, we have 5 times 3, which is 15. You should show your work right over here, right? Add them all up. When we add them all up, we have 153 times 25 to give me a total of 3,825. All right, try this one down here. 400 times 50 is 20,000. We have 400 times 7, that's 280. 50 times 70, that's 3,500. 70 times 7, that's 490. 50 times 2, that's 100. And 7 times 2, which is 14. Again, add those all up. We have 472. Please show your work times 57. That'll equal a total of 26,904. Show that work. Okay. Again, I'm doing this quickly to help you guys save time on your on this video here. This is going to be 14, 56. You can check them. 630, 63, 560, and 1,400. And we add those all up. Whoops, that's 289 times 77 to give us 22,253. All right, and down here, okay, let's read this. Slow down again, Mr. Crone. The 3 generic rectangles below have been partially labeled with dimensions and areas. Complete the missing values on the outside and inside of each rectangle. All right, let's zoom in here. Let's put our attention and our focus on just this one right here, okay? Now, this is a little different. I'm missing a number here. I'm missing a number here, right? And I'm missing a number here, and I'm missing a number here, right? So what we're going to do is we're going to use with the information we do know, with the information that's given to us, how to find the rest of these, right? So I'm looking around, and I see a 10 and a 2. I could multiply those. 10 times 2 would give me 20 down here, wouldn't it? Okay, so I'm a little closer to what I need to be. Now, the trick is I can't get this one because I don't know this one, do I? Or would I? So it'd be really nice if I could get this question mark right there with this 40 to help me. But I can't get the 40 because I don't know what goes up here. So man, am I struggling. So what I'm going to do is I'm going to put my attention on right here. This 2 times what number gives me 4? This has to be a 2, right? 2 times 2 to give me 4. 2 and 2, right? To give me that 4. Once I know that that's a 2, that helps me, right? That helps me because now I can say 2 times what number gives me 40? Ah, that's a 20. Now I've got the last pieces in place to help me finish this. 10 times 20 is 200. Okay. All right, so what happened? I found out you don't have to do this. We just had to find this piece. But what we did find out is 22 times 12, right? That's what we did. 22 on the left side, 12 on top. If you did find the area is 264, okay? All right. I'm going to go a little quicker on this one, and then I'm going to let you try this last one, okay? All right, so for this one, what could I do? All right, well, I see the 400 and I see the 4. 404. So this bottom piece is 4 times 4, which is 16 with 2 zeros at the end, right? I see my 4 and my 5. That would give me 20 down here in the corner. All right, I'm struggling with the rest, so I'm going to use, now I'm going to go back to what I have. I have this spot plus 4 gives me 120, all right? All right, so what number could that be, right? 4 times what number would give me 120? 4 times what gives me 12? That's a 3. I do need a 0, so that would be my 30. Okay, now what can I do? Oh, I can use this 30 and this one, right? 30 times that red circle to give me 2,400. 3 times what number? 8, right? 8 times 3 is 24, and I need another 0 here, right? Because notice I have 1 0 here, that 0 here to give me 2 zeros right there. Okay, so that's 80. All right, the rest of the pieces should fall now into place real simple once I have the outside one. 80 times 400 is 3,200. I'm sorry, 32,000. I need an extra 0. I missed a 0 in there, didn't I? And in the far right, 80 times 5 is 400. I think I have all the pieces. So what I get, I have 435 times 84 to equal 36,540 when you add up those parts. Try this one on your own and come back and check your answer on this one. Okay, now that you've given it a try, I will just place numbers on here and see if yours match up with mine. 500, 70, there's a plus in there, and I have a plus and a 9 here. This becomes 30,000. This one becomes 630, and in the upper right I have 360. Okay, again, this is just check on your own. 576 times 69 equals 39,744. Okay, all right. Hopefully everything goes okay. You're feeling really good about these generic rectangles and with multiplication. Let me know if you have any other questions.